I wanted to go back a little bit about and talk about the stuff that we did last time that we were here. So last time we talked about vectors. So we added some vectors, and let me see where we're at. Um, yeah, so we added some vectors, and I show you two-way to represent them. Not two-way to represent them, but like I show you how to represent them in graphically. But I also showed you how to do operations on them. So the two ways that we talked about to do operations on them, you can add the corresponding terms if you adding two vectors, or you can set them up in a certain way where you know from tip to tail, and that gives you that makes you able to add the vectors together. So now we're gonna do something. We're gonna shift gears a little bit. Now we're gonna talk about matrices. So matrices basically is like a set of numbers that are arranged in rows and columns, but to make a rectangular shape. So you can have a 3 by 4 matrix or a 3 by 3 matrix. When I say rectangular, it could be a square too. So like a square would be considered like a special case of a rectangle. So the way that works is uh you have a ref pen. How's it going? So the way that works is you have those numbers arranged in a certain way where you'll be able to do operations on them. So now what the tricky part is, when we're doing additions and subtraction, it's easy, right? You just add the corresponding terms. But when you start doing multiplication and division, this is where it get tricky. So Lee, what's up? Hey, if you want to see the screen, the best way to do that would be going to YouTube. So now, I'll start by, and I'm showing the screen now. I'll start by telling you guys, uh, how do you name those terms that are in the matrix. So what I have here is a 2 by 2 matrix. So what I have here is a 2 by 2 matrix, 2 rows and 2 columns. So these, like you probably, I mean, it's common sense that you would think these are the rows A and B. I'm in this matrix. A and B's are rows, and C, D rows. And if you think about column, if you think about columns of matrix, A and C are on the first column, and D and B are on the second column. Same thing here to the right. So 1 and 2 row, first row, 3 and 4, second row. So column here. So if we're thinking about column, 1 and 3 on the first column, 2 and 4 on the second column, and that's how you do it. That's how you're able to see that. Now, that's going to be very important for us when we're going to do operations on them, because you can add them. You can have one matrix minus another matrix, two matrix multiplied together. In some cases, you can also divide certain matrices one by the other. So now let's go first and give you guys kind of like the size of the matrix. So let's go with the size. So if you have a matrix this way, the one that we just did, I said it's a 2 by 2 matrix. So the way you name them, you just find the number of rows, 2, and then find a number of column by 2. So in this first case that we had here, so this one matrix here had 2 rows and 2 columns, so it's a 2 by 2 matrix. Now if we have another matrix this way, so if we have another matrix this way, so let's say I have here 3, 4, 6, 8, 9, 7. So if you want to know the dimension of this matrix, of course, what you say is, hey, how many rows do we have in this matrix? How many rows? Um, uh, so how many rows do we have in this matrix? We have 3 rows, right? 1, 2, 3. And how many columns do we have in this matrix? We have 2 columns. The first one right here, and I'll do that on black for no reason at all. This is the first column, and this is the second column. So if you just read in if you want to see the screen, the best way to do that is to go to YouTube channel. Just type, if you depending on where you seeing this, you can just either click on the profile and then go to the YouTube channel. If not, just go on YouTube and type the Jax tutor. That should pop up for you, and then it should show you the live streaming of this. So now I have some examples here that I want to go over. Before I do that, I want to talk about the the places that we have those, how we play, how we name each of those. So that three here is in the first row and also the first column. So three, first row, first column. So that's the matrix. Thank you, Junior. Three is in the first row, first column. That's the position for three. Eight is in the first row, but second column, and that's eight. And four is in the second row, first column. And if this is the first column here, first column, and let me do something that's a little bit less messy. so let's say we have this. Let's start with another -9, 0, 5. So what's the position of 8 here? So eight is you gotta go to Junior, you gotta go to YouTube to see the problem. That's the only way to see it. You gotta go to YouTube to see it. Otherwise, you won't be able to see nothing at all. You won't be able to see it on the screen that you're on now. So you gotta go to YouTube. Go to YouTube and type the Jax tutor. You'll see it. I think you can click on the profile, on my profile here, and it will show you. It will take you directly to YouTube. I think there's a link there. So you just go either way. You can go there and just see it. So what I'm saying is, here we are in the first row in the first column. This is how 8. This is the position of 8. For 9, this is the second column, but this is still the first row, right? So this is the first row. This is the second row, and then if we do it this way, second row, and this one is the third row. So anything that's on this row is on the third row. Anything that's in this row is in the second row. Anything that's in this row is in the first row. So 8 and 9 are in the first row. 6 and 5 are in the second row. -9 and 0 are in the third row. Now the only difference is between -9 and 0, they both on the third row, but they're on different column, right? So this one is in the first column here, and 0 is in the second column. -9 is in the first column, 0 is in the second column, and then if we say first column here, second column here. So now this is how you differentiate them. So now this is going to be very important when we do multiplication, because position is gonna help us a lot. So when you know what row and columns in certain what row and column you have, what position a particular entry is in the matrix, you'll know how to multiply it by another one. So let me give you some examples so that way you understand. So let's say we have we have a matrix A, and I'm using capital letter for A. Let's say we have a matrix A that so let's say we have a matrix A that is what? I have those examples set up. So let's say we have a matrix A that's 4, 3, 3, 2. Now, there's a bunch of stuff we can do with this matrix. The first thing that we can do, we can find the inverse of the matrix. We can find the inverse of a matrix. But it's easy. Let's start with some easy stuff. So let's say we have another matrix called matrix B, and we wanted to add those two matrices together. So this is going to be fairly easy. It's going to look exactly what we would think. It's going to be exactly the same way that we would think. I should have probably put those in a different color. So now, how do I add those? I think this is going to be easy for you guys to understand. A plus B. So how do I add A plus B? So A plus B, how do I add it? So I take the corresponding elements. So this is the first row and first column. I'm going to add it to the first row and the first column of this one. So let me erase this part so that way you understand. So this is the first row, first column, first row, first column. So 4 plus 1. We're done with this entry, right? No, we're done with this entry. So and now let's stay on the first row, but we're in the second column. First row, second column, 3, -1. So 3 minus 1, right? And here, second row, second row, first column, second row, first column. So you add the corresponding entry. So 3 -3 plus 2, 3 plus 2, right? Second row, second column, 2 plus 0. Now this is easy, right? We just add what we have. 1 plus 4 is 5. So a plus b is equal to 1 plus 4 is 5. 3 minus 1 is 2. 2 plus 3 is 5. 2 plus 2. Hopefully I didn't make a mistake on this. 2 plus 0 is 2. So 5, 5, 2, 2. So yeah, that should do it. And this is how you would do this first one. Now, the hard part is not necessarily hard, but the little bit challenging part is multiplication. We're going to get to that. So let's say before we do that, let's say we wanted a minus b. Now, there are two ways that you can think about this. So what we can do is multiply. So I'll show you what I mean. So let's say we have a matrix A. We'll take away a minus b. So we have a matrix A and matrix B. The two ways that we know how to add matrices already. So we can say A minus -b. So we could do this in 2 steps and say, hey, the first thing I want to do is take the negative of b. So what that means is multiply b by a negative number, which will do exactly what you would think. You multiply each of those entries by -1. So you would have, let's see, what is b? So you would have 1 times -1. So basically you would change the sign of each of the elements in the matrix. So you change the signs of this one, change the sign of this, change the sign of this. This will go from a negative to a positive. This is 0. It's still going to stay 0. You can think of it if that's easier for you. But the other way to think of it is saying, okay, I know A, I'm just going to take away B. So I'm going to do whatever I had for A, 4 minus, which is a 1. Whatever I had for A, 3 minus 1. That would give you 3 plus 1. So we can think of it 2 ways. So I have 4, 3, 3, 2. So A is 4, 3, 2, 3, 2. Let me use a different color for no reason at all. Actually, this might help you understand it. A, and I'm using the red for A. 4, 3. Let's see. What's it? A 4, 3, 3, 2. And then B, let's use blue for B, for example. So I have B here, and I want A minus B. B is, what is B? I have my notes here for you guys. What is B? 1, -1, 2, 0. So I want A minus B. So what I could do is A plus -B. And this is not technically probably not the best way to write this, but I want to show you that what we do here. So what I'm going to do, I'm going to take -1, I multiply it by this one, -1 multiplied by this one, -1 multiplied by this, -1 multiplied by this. So what's going to happen is all the entries, all the entries in this matrix, they're going to change sign. So the 2 is going to become a -2, 0 is going to stay the same. And the -1 is going to be a +1. So what we can do is saying this is A plus. We just change the sign of the elements in this inside of this matrix. So -1. This was a +1. It becomes -1. This one was -1. It becomes a +1. Actually, let's just keep it at 1. This is 2. It becomes a -2. This was 0. Stay the same because you multiply 0 by -1 is 0. Okay. So yeah. All right. Cool. So now what's the one in red? The one in red is 4. That's matrix A, 4. This is not a nice looking 4. 3, 3, 2. Right. So what I'm gonna do is take the entry 4, first row, first column. I'm gonna add that to first row, first column in matrix B, and that isn't. It's not really surprising. So until you get to multiplication, those are not really surprising. So first row, first column in this matrix plus first row, first column in this matrix. So 4 minus 1. So what I'm gonna have is 4 minus 1, and I can use a different color for absolutely no reason at all. 4 minus 1, 4 minus 1. I'm going to write it down before I do the operations. 3 plus 1, 3 plus 1. And the reason why I'm adding those is because I already multiplied the second matrix by -1, which changed the sign of everything to a negative number. Now I can just add A plus negative B. So instead of having A minus B, if you can't think of it that way, because especially if this is your first time doing it or first time seeing those, you want to think of it as 2 steps. I'm going to take the negative of the second matrix, A minus B becomes A plus negative B. So what is 2 minus 3? So this one is 3 minus 2, actually it's 2. And then this one is 2 plus 0. 2 plus 0. And this is not, rocket science or voodoo. This is just me adding this entry, first row, first column, to first row, first column in the second matrix. So now what else do? We just add them, right? Correct? My pen is all right, good. So we just add them. What is 4 minus 1? 3. What is 3 minus 2? 1. What is 3 plus 1? 4. What is 2 plus 0? 2. Okay. Let's see if I did this right. 3, 4, 1, 2. Yeah. So that is A minus B. All right, let me know if that makes sense, guys. Questions? So, yeah, Jessica, welcome. Sophie, welcome. Esquivel, welcome. Josh, welcome. Mia, welcome. Elan, I don't want to mess up your name. Junior, what's going on? All right, cool. So if you want to see the screen, the best way to do that is go to YouTube. If you on, depending on where you at, you could just click on the profile and then find a link directly to the YouTube channel. Or you go to youtube.com and type the Jax Tutor. It should pop up. And this live session should pop up and you'll be able to see it. Now, here's the tricky part. Now let's get into some stuff that are a little bit more interesting. Let's say you wanted to find the transpose of a matrix. So what that really means is, swapping the rows and columns for those matrices. So if let's say something was in first row, second column, it's gonna become in second row, first column. Now you may want to ask, okay, why do we need to do that? But it's an easy trick that you can how you can swap those. So they call that, transpose of a matrix. So let's say I have a matrix A here, and I wanted to find a transpose of matrix A. 4, 3, 3, 2. Actually, I can do that with another one that doesn't have the same numbers, so you understand where everything is coming from. Let's do it with B, because B, all the numbers in the matrix B are different. All the entries are different. So B, so let's say this is 1, -1, 2, 0. What I would do here is, so this is, you see how this is first row, first column. So because it's 1, 1, first row, first column is going to remain first row, first column. So what I will do is swap in the position between the rows and columns. So like I was saying, if something was in third row, second column, it's gonna be in second row, third column. So we're gonna swap those. So that means the transpose of this, whatever was in first row. So what's gonna happen is If you have a square matrix, whatever was in first row, first column, whatever was in the principal diagonal line, it's going to stay the same because it's going to have first row, first column, second row, second column, third row, third column, fourth row, fourth column, and so on and so forth. These are going to stay the same because they're not going to. There's no, even if you swap 3 and 3, you still get 3 and 3. So now this one is the 0 is going to stay the same. 1, 0 is going to stay the same because the first row, first column, second row, second column. Now you see how 2 was in a second row, first column. So 2 was second row, 2 is in second row, first column. So what's going to happen when we swap them, 2 is going to become in, it's not going to be in the second row. So the second part is going to be second column, and first row. So now second column this is the first column right here, and this is the second column. 2 is going to be in this column, first row. Second column, first row. 2 is going to be here. -1 was in first row, second column. Now it's going to become it's going to turn into something that's in second row, first column. And -1, of course, you could probably see where it's at. Now, this gets more fun when you get to like a 3x3 matrix or a 4x4 matrix. It's getting a little bit more fun, a little bit more complicated too. But this is how you find the transpose of this matrix. Now, what else we can find? How about we need to find the inverse of a matrix? Now, we can find the inverse of a matrix. If you want to see the screen, the best way to do that is to go to YouTube. You can go click on the profile here and see, and just type, and just go directly to YouTube, or you can go to youtube.com and type the Jax tutor. You'll be able to see that easily. So, now how do we find the inverse of a matrix? And this is so this is not something that you would think. Now, and if you have I'd say you have 3. If you want the inverse of 3, all you have to do is saying that, okay, 1/3, the inverse, this is not equal to 3. So if you want the inverse of 3, so all you have to do is just flip it, 1/3, right? But in matrices, it doesn't work like that. You don't have 1 over some matrix here. You don't have that. It doesn't work that way. That's not what they call the inverse. So what they call the inverse is 1. Let me see. And then you're going to find the determinant of the matrix. And then you're going to do some tricky stuff to this matrix right here. You're going to change some stuff, change the sign of certain things, and then some of the stuff you're going to change their place. Now, how do we find that? Now, how do we find the determinant of this matrix? The determinant of the matrix, so what it really means is, and if you guys probably have seen this before, so let's say I have this matrix A here. If I want the determinant of the matrix A, so it's 4, 3, 3, 2, all I have to do is multiply the elements in the principal diagonal, in the first diagonal, by minus this times this. So what I'm doing, and let me put this. So 4 multiplied by 2, and I'm going to put this at here so you can understand where this comes from. 4 times 2 is 8. 4 multiplied by 2. And then I'm going to take that away from minus 3 times 3 is 9. The minus 9. What is 8 minus 9? So the determinant of this matrix is -1. So the determinant of the matrix is -1. Now, how do we find the inverse? Now you would think that you would take the inverse, you just multiply this by the first matrix to find the inverse. No. You still got to do some tricks to the first matrix that you started with. So I'm going to change the sign of everything that was in the main diagonal, and then I'm going to change everything else that wasn't, that was not, everything else I'm going to change them place. So the matrix A was 4, 3, 3, 2. I'm going to change the sign of these, -2, -2. And then this, I'm going to swap in place. So 3 and 3 basically still stay the same. So this is 3, this is 3. Otherwise, if I had a different number here, I would swap them place. I would switch the place out. So now still got to multiply all of this by 1 divided by the determinant of the matrix, which was -1. And that's how you find the A inverse of the matrix. So what we have is A inverse of A is equal to -1. 1 divided by -1 is -1 still. Hey, Lazy, how you doing? 1 divided by -1 is -1. And then you got to multiply all of that by this matrix, this new matrix that we have here. So how do we find that? 1 times -4 is 4, correct? 1 times -4 is 4. And actually, I think I did this backward. So the ones that you change, the new matrix that we have here, actually, let me go back. I got carried away. So, okay, so this one, you change those sign here. So this was 3 has become -3. This was 2. It becomes what? Negative. The 2 and the 4 is going to change the place. So this was the 4 here, was in the first row, first column. So we replace that by the 2. And the 4 is in the second row, second column. So what we did here is, that was A. I'm going to show you what A looked like before we did all that stuff to it. A was what? It was a 4 here, was a 3, and a 3, and a 2, right? So what we did to A, we swap those places. So the 2 becomes here, and the 4 goes there. So 4 go here, 2 go here. And then we change the sign of these. -3, -3. All right, cool. So this is the new matrix. That's all we have to multiply by the determinant. How do we do that? Thank you, Ashley. Simon, welcome. Jordan, welcome. Ashley, welcome. Fox, welcome. So how do we do that? We multiply this by -1. And that's all we have, a -1 times this new matrix that we found here. Let me do it this right here in a different color for no reason at all. -1 times, I'll do it on this side so you understand. -1s multiply by this matrix 2, -3, -3, 4, right? So -1 times 2, -2. -1s times -3, 3. -1 times -3 again, 3. -1 multiplied by 4, -4. And this is the inverse of A. This is A inverse. Yeah. So all that work to find A inverse. The last thing I want to show you guys is how to multiply 2 matrices. And I think this should do it. So if you want to divide 2 matrices, actually, you could probably try it on for yourself. So what you would do, you'd find the inverse, and then you multiply. Let's say you have A multiplied by B. So you'd find the inverse of B, and then you multiply A by that. So by B inverse. Catherine, welcome. Sour, welcome. Okay, good. Let's do A times B. Let's remind ourselves what A was. And this is A inverse. So let's remind ourselves what A was first. A was 4, 3, 3, 2. And what was B? B was, what was B? 1, -1, 2, 0. Now let's multiply them. So how do we multiply A times B? First thing you want to do is think about the rows and columns. Think about positions. It's all about positions here. So now here's what I'm gonna show. I'm gonna show you how to think about this, and it's gonna make a whole lot of sense to you. So if I want So let's see the position of, let's say we're gonna have A times B here, A times B. If I want the element here is gonna be in the first row, first column, all I have to do to find this is take the first row of the first matrix, multiply by the first column of the second matrix. So you do a dot product. Not sure you guys I had to do that last time. So you take the first row or dot product between the elements of the first row of the first matrix, multiply by the first column of the second matrix. So I want this position right here. It's called first. It's the position first row, first column. This one right here that I'm this red circle that I'm showing here, and I'm going to do them in different position in a different color, so you understand that each one of them has a has a different position. Right here, this one right here that I need. Let's do this in black, for example. So let's do this in black. So this one right here that I need, it's in the position first row, first column. So what I'm going to do is take in the first row of the first matrix and then do a dot product between that and the first column of the second matrix. So first row, first column. So it's the first row of the first matrix, first row, first column. You multiply that by the first column of the second matrix. So what I do is 4, 3. That's the first row. First column of this matrix is 1, 2. I'm going to do a dot product. So it's 4 times 1 plus 3 times 2. So let me repeat. If I want the elements of n that's going to be in the first row, first column, all I have to do is take the first row of the first matrix, do dot product with the first column of the second matrix. And that should do it. That should do it for this one. Now, this entry is fine. Now, let's go to the second entry here. What is this entry called? This is still the first row, because you can see this is still in the same row, first row, but matrices. That's what we learned. So this is still in the first row, but it's in the second column. Let me use a different color for it. And I want to make sure that you guys get this, because it gets very confusing. So this element right here that's going to be here is still in the first row, but it's in the second column. So what I'm going to do to find the element that's in the first row, second column, what I'm doing is take the first row of the first matrix, multiply by the second column of the second matrix. So first row, second column. First row of the first matrix, multiply by the second column of the second matrix. So first row of the first matrix, 4, 3, multiply that, a dot product, with the second column of the second matrix. So first row, the position is going to be first row, second column. First row of the first matrix, second column of the second matrix. And that's how you know which elements you're going to multiply by which element, because it doesn't work out the way that you would think when you have the 4 multiplied by 1, 3 multiplied by -1. Otherwise, this would be a piece of cake. Now, the way they make it interesting for us is, if you want to find the element that's in the first row, second column of the result, the matrix that you're going to have, you take the first row of the first matrix, multiply that by the second column of the second matrix. It's a dot product, just like I showed you guys. You do dot product. So first row, second column of the second matrix. First row, second column, that's the position. First row of the first matrix, second column of the second matrix. So what's the first row? 4, 3, second column, -1, 0. So 4 times -1, 4 times -1, and I'm going to write it this way so you understand what I'm doing, plus 3 times 0, 3 times 0. Now, so we found the first row, second column. Now, what's this position here? Let me change color for no reason at all. Green. So what's this position here? Who can tell me what this position here is? What position is this? Who can tell me what position is this? This is the second row. So this is row 1, row 2. Second row, what column is this? First column, because it's not on the second column. So if I need the elements that's going to be the entries that's going to be in the second row, first column, all I have to do is take the second row of the first matrix, multiply it by, do a dot product from that, and the first column of the second matrix. So the position is going to be, the resulting position is going to be second row, first column. So I take the second row of the first matrix, multiply that by the first column of the second matrix. So first row, second column, second row, first column, second row of first matrix, first column of the second matrix. So Elena, welcome. Olivia, welcome. Cookies, welcome. So second row here of the first matrix, multiply by the first column of the second matrix. This element, the resulting element is going to be, that resulting entry is going to be in the position, second row, first column. So what I do, 3 multiplied by 1 plus 2 multiplied by 2. And that should do it for this entry. And that's it. So now the last entry, let me change color for no reason at all. Purple maybe, or pink. I think we can try pink. All right, so the last entry is the second row, second column. So what I'll do is take the second row of the first matrix. If you want to see the screen, go to YouTube and just type the Jax tutor. That's the easiest way to see the screen. So the last row, the last entry of this matrix is second row, second column. So I'm going to take the second row of the first matrix, multiply by the second column of the second matrix. The second row, this is the second row, and this is the second column. So I'm focusing on the ones on the pink, 3 times -1, 3 times -1. And if you do it this way, it should be easy. 2 times plus 2 times 0. Okay. Let me scroll up. All right. So all we need is this to solve for it. Welcome, Rebecca, Anthony. So all we need now is this to solve for it. It's simple, calculation, algebra, whatever you want to call it, manipulation, whatever you want to call it. We can do that in black. So let's do everything else in black. A times B. What's 4 times 1? 4 plus 4 times 3 times 6. 3 times 2, 6. 4 plus 6 is 10. 3 times 1, 3. 2 times 2, 4. 3 plus 4, 7. Right? And on this side, we have 4 times -1, which is -4. 3 times 0, I think that was here, which is 0. So what we end up with on this here is -4. And 3 times -1, -3, 2 times 0. So you end up with -3. Okay. And that should do it. That's all. So the thing to remember in this is, if you were finding, so I use entries to help me remember which one, which rows, and I need to multiply by which columns. If I want to find the first row, second column entry, so when I take the first row of the first matrix, multiply by the second column of the second matrix. Of course, you do a dot product. So that's how you do that. Okay, I think this should do it for this one. Let me see what you guys have for me. Okay, I'm trying to see if we on I'm trying to see if this is on Facebook too, which I don't think so. I may have messed up the connection on Facebook. Okay, so good. This is it, guys. This is it. And let me see. Gabe, welcome. Wandley, welcome. Anthony, Rebecca, welcome. All right, guys. This is it for tonight, and that's all I wanted to show you. So we went over matrices. I showed you how to add them, multiply them, and we went over transpose of a matrix, determinant of a matrix. And Gabe, welcome. Haley, welcome. Curry, welcome. So that's all we went over for Derry, welcome. So that's all we went over for tonight. And if you guys have any, if you want to see the screen, actually, if you want to see the replay, you can go to YouTube and you'll be able to see everything. Yeah, that's it, guys, and that's it. That's all I have for you guys tonight. And thank you for stopping by, and I'll see you guys another time. Thanks. Bye.